So my name is Nars, never mind the rest of the name. I started the paving industry in 1990 as a project engineer and have held several different positions over the last couple of years. Today I'm the application and technology specialist for the working group, Vogel Asphalt Pavers. So we were asked to speak about best practices in paving, latest technology, and apply it all to sustainability. Now I noticed the word sustainability is not in our topic, but that's what we were asked to present. That's the presentation I put together. Since last week and today I've spoken in South Carolina probably 3 times. And best practice paving 101 from the day the free-floating screed was developed to today is still the same. The only thing that changed is technology. So that's why we'll tie some technology with our presentations today and show you what are some of the things we focus on in terms of sustainability. So sustainability is something that we have been working on for several years now. It's do it right the first time. One of NAPA's old slogan was get in, get out, and stay out. That means do it right the first time. That's your first step in sustainability, so we don't have to come back. There's billions of dollars. You notice there's a couple of question marks there. They said roughly 10% of all the money spent on construction is spent on rework. Roughly $30 billion. So we can start there with sustainability. Today's equipment are designed with features to optimize quality and performance. Those are some of the things that we're going to focus on. We know the life of the pavement is dependent on density and smoothness. So those are the things we will focus on today. So we ask you in terms of sustainability, follow the best practice, do it right the first time, get in, get out, and stay out. Lay it the way it should be laid so the pavement life is to what it was designed for. So we'll show you some features that are being designed today to allow you to monitor your project off-site. You can sit in your office and see what's going on. You can sit in your office and see what the machine is doing. You can sit in your office and see what the temperature coming out of the back of the screed. So those are some technology we'll show you. And then we'll end with what are NAPA and some of the other folks doing today in terms of managing the. All right. What is paving? Paving is really laying a mixture of hot aggregate, sand, asphalt cement, and air pockets to a certain width and depth. So in the paving process, once we set the width and we set the depth, all we're doing is pushing out the air pockets. That's all we're doing. Starting with the screed and then finishing up with the rollers. So if we take a look at a mix design, let's say we're looking at a half-inch mix design there. The job mix formula says 3/4 inch, 100% passing, half-inch mix, 98% passing, which means we roughly have 2% half-inch aggregate in that mix. And we have 89% passing of 3/8. That means 11% of that mix has half-inch aggregate and 3/8 aggregate. But if we go down to the fines, 67%. So that means roughly 67% of that mix have fines in it. Now what does all of that mean? Let's take a look at it. And then we add asphalt in it, 4.9% binder. We mix it to 300 degrees. So let's take a 1-foot container of this mix. With the asphalt, 300 degrees. And then we try to compact it. The screed's going to compact it X amount, may get you about 85% density. The heavier the screed is, the more you can push that air pockets out. So a lighter screed may give you 75, 78% density. A heavier screed may give you 85, 90% density. A high compaction screed will probably get you 98% density, which we don't want. So it depends on the type of screed, the weight of your screed, we will push X amount of air pockets out. So in that mix, we have the mixed internal frictional resistance. As we're compacting that mix, what is happening? The fines are acting as ball bearings, and the asphalt are acting as a lubricant to allow the larger aggregate to move, to push some of that air pockets out. So if that temperature drop a certain degree, the viscosity of the asphalt changes. When the viscosity of the asphalt changes, the ability for the larger aggregate to move becomes a little bit stiffer, becomes a little bit more difficult because the viscosity change. So that will impact how much we can compact that material. If we change the fines, we change the ball bearings, we change the ability of the larger aggregate again to move, and that will affect how much air pockets we pushed out. That will affect the density coming out of the back of the screed. When does all of that happen? Well, we all know if we sit and wait 20, 30 minutes for the next rung of truck, the asphalt in front of the screed will get cooler, it got stiffer, so things will change. When we dumping the truck, last half a ton of mix coming out of the truck will be different gradation because we segregate the material. So anytime we handle the material, if we change the consistency of the material, we change the internal frictional resistance, we change the ability to compact the material, whether it's under the screed or whether it's on the roller. Why do we use the big material transfer in front of the paver? We use the big material transfer to ensure consistency of the material, to keep the internal frictional resistance of that material consistent so that our compaction remains the same. So in the next hour, that's what we'll be looking at. And by the way, that's paving 101. You guys can all leave now. So after the paver, we compact it with a couple of rollers to get our final density 92, 93% depending on where we're at. So that means we have about 7% air voids left in that mix. That's our magic number. That's where we want to be. If you take a look at this hopper insert, that is the mix in the insert in the paver hopper. You can see a whole bunch of fines here, and you can see very little fines there. When that mix get under the screed, more than likely we will see something like that. Not enough fines means not enough asphalt. After compaction, we want the asphalt to go from a lubricant to a glue to hold the larger aggregates together. So if we don't have the fines, we don't have the heat, we don't have the asphalt, because the asphalt generally is in the fines, the heat is in the fines. So we change the mix consistency there, we change the mix consistency there. We don't have enough glue to hold the large racks together, we end up with premature failure. No. All right, let's take a look at how this screed compacts the material. So this is a side view of a screed. There's your depth crank, there's your pivot pin, there's your screed arm, there's your screed plate, that's your strike off in front of the screed, that's the trailing edge of your screed plate. What's the last thing that touches the asphalt? The trailing edge of the screed plate. How many times you go out on a job site and you see daylight between the trailing edge and the asphalt? That means something's not working right. You have a problem. Now, what is screed compaction? There is the front of the screed, that's your strike off. So as we pull the screed forward, the strike off strikes off that amount of material which eventually will get compacted. The trailing edge is the last thing that touches the asphalt, so our screed compaction is from there to there. Everybody get that? That's simple, right? All we're doing is we're hauling a hunk of steel. We're feeding asphalt and we're hauling a hunk of steel. That's all we're doing when we're paving. But that hunk of steel could be 3 hunks of steel because we all run extendable screeds. So if the extension on the left side, the extension on the right side is not doing exactly that, then we're hauling 3 hunks of steel. Then we'll have 3 different compaction. And so we'll come back and look at what is important with an extendable screed to ensure that all 3 screed sections are shearing the material off at that point, and all 3 screed sections are compacting the material at that point. Then we have consistency from end gate to end gate. And then we will look at how do we maintain consistency of the material from the plant to the job site. Okay, so there are several types of screed out there. These are vibratory screed, so we get our compaction with angle of attack. These are compaction and high compaction screed. Just to quickly give you guys an idea, these screeds will get you an average of 85% density. These screeds will get you an average of 92% density. These screeds will get you an average of 100% density. We don't want that, but with coal recycling material, yes, we do. Because of these high compaction screed, there's a process in Europe, and I'll give you a quick video of that, not to get you off topic here. This process is called inline pave. 2 pavers 4 foot apart. 4 foot apart, the paver in the front laying the binder 3 inches. 4 foot behind it, the second paver laying the surface mix with a compaction screed. So the screed in the front is a high compaction screed, 93% density, no rolling. The screed in the back, laying your surface mix. The lighting is pretty bad here. Can you guys see that clearly? There's a transfer conveyor that sits on top of the first paver that transfers your surface mix to the paver at the back. You notice the guy walking on the mat and you can't see any footprint because we're up to 93% density. You notice everybody's in raincoat. It was 32 degrees, it was snowing and raining, and we were laying surface because it's hot and hot. There's a transfer conveyor that transfers your surface mix to the paver at the back.
You know what country this is?
That was Germany. That is how they pave in Europe today. Why can't we do that over here? We can have 2 trains in echelon doing 2 lifts. So 2 paving train in echelon 100 feet apart, hot to hot, hot on hot, bridge deck to bridge deck, no joints. What's the first thing that fails on our roads? The joints. So if we can go bridge deck to bridge deck, then we eliminate all the joints. 1 traffic control, no tack. We don't have to wait for 45 and rising because it's hot on hot. That's a new process in Europe. There's probably 12 of those paving trains working across Europe as we speak. But let's come back to Earth. Come back to the United States. Okay, so that's how we gain compaction. Vibratory screed, compaction screed, high compaction screed. If you guys realize, there's a section of I-26 about 30 miles from here. I found out yesterday they laid 2 6-inch lifts. It's the roughest road I ever rode on. 2 lifts at the same time. It's very difficult to maintain smoothness. The thicker you pave, the more density you want coming out of the screed, so less you rely on the roller because the roller creates waves the thicker you pave. A high compaction screed will get you 93%, 92% density right coming out right from the back of the screed. Okay, now let's look at what happens when we're paving. So we know the tractor has 2 conveyors. The conveyor delivers the mix to the augers, and the auger spreads the mix. The tractor pulls the screed at that point. Our screed consists of the screed arm, or the leveling arm, sorry, the screed arm, our main and extension screed, which is attached to the screed arm on 2 pivot pin, 1 on each side. So if we're not turning that screw, the screed is that plus that being pulled by the tractor at that point. So the hunk of steel I talked about earlier is that plus that plus that. It's 1 hunk of steel that we're hauling. The tractor delivers the mix to the auger spreads the mix. So as the tractor pulls the screed forward, the head of material pushes against the screed. It can't go back, so what would happen? It has to go up. The weight of the screed is pushing back down. That will create a balance. That balance will determine our mat depth. So we can simplify that equation real quick. The weight of the screed is fixed. We can't change that. The head of material, we always say a good rule of thumb is bottom of the augers 2 inches above the mat, set your auger sensors to cover about half the auger shaft. Every paver today, if you know what you're doing, you can do that. So we can take the head of material out of the equation also. So what's left? How high you put that toe point. And that's why it's important that we always lecture you guys, both guys use a screw or both guys use a toe point, but not 1 each. Because that determines your line of pull. So if we set that right, that's fixed. That's the only thing that determines our mat depth. And we know if we run that too high, we use our screw to bring it back down, and next thing you know, we're paving like that rather than like that. If we bury the augers with material because we're too lazy to set it right, we got way too much material. That force becomes so high, it pushes your mat up to 3 inches, but you're looking for 2. Next thing you know, you're cranking the screw again, and you lose your angle. So it's important, get the right head of material, get the right line of pull, and I can't tell you what your number and your toe point should be because every paver is different. You can't use the same rule of thumb for all pavers. If you look at a Road Tech paver, on the toe point scale, 0 is at the bottom. you go from 0 to 12. If you look at a CAT or a Blanox paver, 0 is in the middle. If you look at a Vogler paver, 0 is 4 inches below. So you have to know your paver, you have to know exactly where to put that to have the ideal line of pull. Why we use material transfer? We use material transfer to maintain consistency of the material and don't disturb the forces. Now, the two forces that I did not mention here is the compacting force. So due to the angle of attack of the screed, we're compacting the material from that point to that point. That's creating a compacting force. That compacting force will change if we change the internal frictional resistance of the material, which will change if we segregate the material. So to keep the compacting force consistent and the frictional force consistent, we need to ensure material consistency. So to maintain consistency of those 5 forces, we use a material transfer. Don't stop the paver to exchange rock. Ensure remixing of your end of load and start of load segregation. Any of these material transfer can get the job done. The challenge with a smaller material transfer is running that insert empty. I'll show you some videos later with running that insert empty, what happens to the material that's flowing under the screed. Not all mix segregate, but you have to be careful, you have to know your material. So what happens when you stop? So the screed floats on the asphalt like a water skier, 5 forces hold it to grade. When we stop the paver, of course the screed will settle. Depending on how long we stop, the mix cools down, the viscosity of the asphalt goes up, the compacting force goes up, and that pushes the screed up to give you a hump. But today's design, I know we do, I know CAT does, when you stop the paver, the screed goes into a hydraulic lock, so it doesn't settle. When you take off, there's a feature called screed freeze on our paver. CAT has it also. It locks the screed to prevent it from giving you a hump. So for about 4 seconds or 18 inches, the screed is locked, it's not floating. It goes past the cold mix, and then it goes back to floating. So all of that happens automatically. So in the past, nobody wants to stop. We want to continue. We want to go from 20 feet a minute to 5 feet a minute until the next truck cycle comes. And in doing that, you're consuming all the mix in the material transfer, you're consuming all the mix in the insert, and you're ending up with segregated material. So if you have the right features, stop whilst your insert is half full, stop whilst your material transfer is half full. Wait for your next truck cycle, keep on paving. As long as you have the right features to prevent settling and prevent hump. So these are your 5 forces. Once again, the tractor pulls the screed at that point, the head of material pushes the screed up, the weight pushes back down. So the heavier the screed is, the more you will compact the material. The lighter the screed is, less density you have coming out of the screed. So today's screed are probably 1,000 pounds heavier than what we had in the past. And they're more rigid. We have front mount screed, we have rear mount screeds. But if you go back to the equation, weight is weight, not front mount, not rear mount. If you have a front mount screed that is as heavy and as rigid as a rear mount screed, your density is the same. The challenge with this screed compared to this screed is because of that narrow extension, you have one more adjustment to play with. Operators that are used to rear mount screed will go in a front mount screed and says, well, it's not paving right because you didn't adjust it properly. And we'll walk you through that adjustment here shortly. So like I showed you earlier, we have compaction and high compaction screed in the rest of the world, and we have screeds that could go up to 65 feet wide. Why do we do that? Because we know the first thing that fails in the road is the joint. So anytime you can eliminate the joint, you pull the whole road in one pass. We can't do that in many roads over here because we can't shut the road down. But some states today, Wisconsin is doing it, Minnesota is doing it, you shut the roads down Friday afternoon or open it back to traffic Monday morning. Pull as much lanes as you can to eliminate the joints. But if you have the right screed, you have a rigid screed, you have a heavy screed, you can do that. So weight is fixed. The next one is head of material. What are the things we need to do to ensure consistency of the head of material? Every paver today has the controls for you to be able to set your conveyors and augers to deliver what you're putting down so you keep that head force consistent. Set the augers to cover half the auger shaft and set your conveyor to deliver what you're putting down, and that will give you consistency of the material head force. So the last two forces where the big challenge is. Your frictional force and your reaction force. That has to do with material consistency, and that has to do with adjustments because we have 3 screed sections. So to manage the last two forces, we need to make sure that we maintain material consistency and our screed is adjusted correctly. So let's go back to adjustment. Tommy is here, he will finish up. Keep track of my time, Tommy. Okay, so here's the main screed. That's a rear mount screed. So the distance from here to here is the same from here to there. So the angle of attack of the main screed and the extension screed usually change the same. Match height allows you to raise and lower the extension screed to put the trailing edge on the same plane as the main screed, so the mat under the extension is the same as the mat depth under the main screed. The angle of attack gives you your compaction. So if the extension is striking the material off in the same height as the main screed, then our density will be the same. So match height will determine your depth, angle of attack will determine your density. So if the angle of attack of the extension is different from the main screed, you will have different compaction. Unequal with front mount screed, same thing, the match height allows you to raise and lower the extension to put the trailing edge on the same plane as the main. But because that extension is narrower than the main, we have what we call an extension independent angle of attack adjustment. Every narrow extension screed have that adjustment either coming out of the end gate or sticking above the screed. When you turn that adjustment, it will either raise or lower the front of the extension screed to allow you to position the leading edge at the same height as the main screed, so our compaction under the extension is the same. How do you know when it's not the same? If the mat under the extension look looser than the main, then you need to raise that angle. Give it some more compaction. If the mat under the extension looks much tighter than the main, it means we have too much angle. Okay, so you always have to look at your texture coming out at the back of the extension to make sure that that matches that. So if I see a line here, it means my extension trailing edge is higher than my main. If I see a line here, it means my extension trailing edge is lower than my main. But there's a risky thing that goes on with these front mount screed. Because that extension is in front of the main screed, they all have an inside slope, 1/16, 1/8, depending on whose screed it is. Means that extension could probably be an 8 to 3/16 lower than the main screed before you start seeing that line. So rigidity of the extension is important. Your guide tube bushing, wear and tear is important, so that when we make that adjustment, whether we're doing 12 feet or we're doing 28 feet or we're doing 30 feet, it holds that adjustment. So we have the same density from end gate to end gate and the same depth from end gate to end gate. If everything is adjusted correctly, that's what we get. Let's see what happens here. That's a rear mount screed, and you can tell, you can see the difference in texture from here to there. But if our trailing edges are on the same plane, same height, it means the mat will be flat. So if I put a straight edge across that mat before it's rolled, it will be flat. But let's look at what the extension is doing. The extension is sharing the material, so that much more material between the blue line and the red line is getting compacted by the extension screed. So I may be getting maybe 80% density here and 85% density over here. So if I'm looking for 92, I've got to push only 7% more air pockets out. Whereas over here, a whole lot more. So I'll have much more roll down here than I will here. So after rolling, you put a straight edge back on that mat and it'll be like this. Because we already have 90% or 85% density here and 80% over here. Because we're compacting that much more material under the extension. But the mat is telling you something's not right. The shinier it is, it means more density, less air pockets. Same situation with a front mount screed. The extension screed Leading edge is much higher than the main screed, so the extension is compacting that much more material than the main. If that was much more significant than that, then the screed will climb. But within reason, it will compact and push a little bit more air pocket out, so you have more in-place density under the extension screed than under the main screed. So again, when we try to roll it, there's not much more air pocket we can push out of there as compared to here. So before rolling, you put a straight edge on it, it's flat. After rolling, we have less compaction here, more compaction here, and you get a dip. But again, the math is telling you something's not right. But the worst thing about this situation is, because the extension is in the front, if both extensions were adjusted like that, you have a 10-foot screed, you're doing a 12-foot lane, who's doing most of the paving? The narrow extension. So the screed is riding on that narrow extension instead of the main screed. And I'll show you a picture later. In that kind of situation, if you suspect that's what's happening, you raise your extension, raise it until you see a significant line there, and then start bringing it back down slowly until you see that line disappear or closely about to disappear. That's when you know that your extension match height is correct. If the texture is significantly different, then it's angle of attack. So texture difference, angle of attack, lines, match height. So to avoid a situation where you suspect that both extensions are doing your paving and not your main, you raise the extension, slowly bring it down until you see a slight line there. As long as the texture is the same and the roller knocks that line out with one pass, you should be good. We're going to have any fights on that? Any argument on that? Okay? That's just good rule of thumb when you're running an unequal front mount screeds. And I do understand this state's got a large percentage of unequal with front mount screeds. Okay, what's going on here? We have the good, the bad, and the ugly. We give up on that one. Looks like we don't have enough angle of attack here. Not too bad, but I don't know if you can see it, but you can see a slight shadow in the middle of the screed, and you can see the difference in texture between both extensions. So both extensions are compacting more than the main screed. Not good. A little bit more angle, that's all over the place. So I'll come back to this picture when we end the presentation and show you blemish created by the material inconsistency, which is segregation. So when you see blemish, the first thing you have to do is ask yourself, is it created by screed adjustment or is it created by material inconsistency? So we'll end with that. This is the one I told you about earlier. I got on that job, the mat wasn't looking right. I was seeing that streak in the middle. I'm going, all right, what the hell is going on here? So I grab my match height switch, I start raising my extension, and you can see how the main screed starts to come down on the mat. Both extensions were running too high. So when in doubt, just raise the extension, slowly bring it down until you see the slight line at the edge of the main screed. Then you know your main screed is paving, your main screed is carrying your extension, not vice versa. If you want to be a good foreman, you want to be a good screed guy, you should always get under your screed with a straight edge or a string line. If you suspect it, get under it with a string line or a straight edge. And it's a real simple exercise. I'm not going to go through the whole thing right now, but you start with your main screed flat, both toe points are zero, null your screw, ensure that your main screed is flat. String line it or use a long straight edge, make sure there's no crung, no invert. We grab a straight edge, we hold it flat against the main screed, we bring the extension down to touch the straight edge. Unequal with front mount screed, we should see about a 3/16 gap in front there. That's a built-in angle of attack because the extension is narrower than the main screed. Now, we can grab our straight edge, we can go on the inside, hold it flat against the main screed, and now we should see about a 16 to an 1/8 of an inch gap. That's what we refer to as the inside slope. So when we run that screed in and out, it does not scuff the mat. Now we can check our parallelism real quick. We'll bring our straight edge back out on the outside, and we can run that extension out and watch it barely scrape that straight edge or push it down, push it up slightly, about a 30-second, 16, maybe you're still within reason. Now that's a quick check. Now because we pave with angle of attack, right now we're flat. If I put an angle of attack in the screed, my leading edge, my trailing edge of my extension is higher than the main. Now I use my match height and bring it down about 3/16. That's a good place to start. That's a good place to pull off the joint. Now, if you know you did that and you zero your match height scale, you know that your match height is now 0 because you put the straight edge on it. That's a good visual check as you're paving to know that your match height is in the right position. And the next morning, if you want to verify your screed real quick, you get under your knees and you look at that extension trailing edge relative to the main screed about 3/16 below. If you train yourself well, 30 seconds to get on your knees, go down there, look at it, you should be able to quickly tell if your screed adjustment is correct. Rather than have to chase it on the fly, not knowing where you're at. Okay, so those are some of the adjustments that are critical. Let's look at segregation now. We said the last 2 fours, to manage it, we need to make sure all our adjustments are correct, and we need to ensure material consistency. So material consistency could only change if we segregate the material from the plant to the job site. The material could only segregate when we're handling it. When we create a slope face on a pile, then the larger stones could roll away. So to manage the material force, we need to ensure that we have consistency of the material. Even though we use a material transfer, we can have segregation. So there are 2 types of segregation. There's gradation or mechanical segregation. That's where the gradation of the mix changes because of segregation. And that could only happen during handling. Then we have thermal segregation, where thermal segregation could be just cold material. We didn't tarp the truck properly. We sit for 30 minutes, wait for the next truck cycle, the mix got cold. When we have thermal segregation, we change the viscosity of the asphalt, we change the lubricant, we change the ability of the large stones to move to push those air pockets out. And that will change our density. So that could be from cold material, but because we have gradation segregation, it means we don't have any fines there. Lower temperature, no asphalt. Premature failure. Now here's an insert. We're feeding an insert here with a material transfer. And that could be an all-day process. When will those stones stop rolling? When it hits the first object, which would be the walls of the insert. Everything that collected in the front and the rear wall gets remixed with the flight chain as the flight chain is pulling the material through. Anything that hits the side wall will slip down, hit the outer edge of the conveyor tunnel, get dragged and dropped by the bearing hanger, which is the wheel pad. So if I take a knife and I cut that section and pull it out, what would I have? Large stones. So if I run that insert empty, all that segregated material will eventually flow under the screed with no fines. That's why we always preach, don't run your insert empty, don't run your material transfer empty. Now, not all mix segregates. That's a 19 millimeter mix. This is also a 19 millimeter mix. Oops, wrong one. Played that one already. That's also a 19 millimeter mix, but that's a polymer mix. It's more gooey, it's more sticky. The stones can't roll as freely as the previous mix. Well, we also use a baffle to allow the material to funnel straight into the flight chain and not roll on the pile. It's just a different insert design. Premature failure, or location 4. Now, some states are using a thermal camera. Why are we using a thermal camera? We don't need a thermal camera to tell us we got a problem there. But too many people don't know that. So other states are mandating it. So what happened in that process? Segregated material flow under the screed. It changed the internal frictional of the resistance of the material. It changed the behavior of the screed. And then not too long after, you get this. You guys seen that before, right? That's every truck exchange with the material transfer. I took a picture of this one 2 weeks ago in Florida. It was just open to traffic. You can see every truck exchange. And they had a big material transfer on the job. So that's what would happen if we don't handle the material right when we're delivering it to the material transfer and the insert and the paver. So what you see there more than likely come from running that insert empty. If we're dumping trucks, the truck load at the plant, mix is prone to segregation. As we travel from the plant to the job site, all the large stones on the top of the truck bed will trickle down to the sidewall. Now we dump it in the paver, the truck pulls out and the operator dumps the hopper. Now all those large stones are in the middle, drops in the middle, and the auger spreads it as we pave along and form a V. What not to do? Can you see any fines there? I think I preached that one enough. These are streaks. These are streaks that are created as the tractor is delivering the mix to the screed. That's the last time we'll handle it. So if we don't have the proper auger flights, we don't use the proper auger extensions and tunnel extensions, we will end up with segregation under the auger box or a blemish or segregation in the wheel pad. And then a few years or so later, we end up with that. Crack seal. So how do we minimize all of that? We start with kicker paddles. Almost all pavers out there have the ability to reverse these flights. Some paver comes with the kicker paddle kicking towards the middle of the paver on left and right. So all you're doing there is just pushing that segregated material, tucking it under the auger box rather than moving it out from under the box. So you have the ability to rotate those flights to allow it to push the material out rather than tucking it in the middle. And of course, if the segregation is in this area here, you have to watch what's going on in the insert. So how do we manage all of that? From the plant to the screed, we handle that material 5 times. When we load the truck, when the truck's feeding the material transfer, because of hauling, if you don't tarp it properly, we can have crust and have thermal segregation, not gradation. And now the material transfer is delivering it to the insert. And then the last time is when the tractor is delivering it to the screed. So what are all the mixing? Let's look at each one of those locations and see how we can remix that material every time we handle it. So the first one is any segregated material that comes along the sidewall of the truck bed. If you look at all the material transfers out there, they have remixing augers on the outside. So the large stones from the sidewall drops here, and as the augers are moving it to the center, to the flight chain or the belt, it remixes it. If you look closely, you'll see some segregated material in this truck bed. Right here. But you can also see how much segregated material is up on the top side there. And that's a 1/2-inch mix design. So if your augers are worn or broken, replace them, because that's what they do. They remix that end of load, that segregated material coming out on the side of the truck bed. When the truck pulls out, you want to dump your hopper real quick. Because if you sit there and wait, then you will end up with segregated material and you will have nothing to remix it with. If you're paving wide and you have a small material transfer, you may want to do that. If you're consuming a lot of material, to avoid the insert running low, you have to be quick with your truck exchange. As soon as that tire hit the material transfer, boom, the tailgate flipped open, material starts to flow. So we don't allow the insert to get low. When the truck pulls out, dump your hopper so that the augers can remix any segregated material that's sitting in there. That's how we can maintain material consistency. Tarp your truck properly, make sure that you don't have crust. If you look, this truck start dumping here, we took a thermal camera, we took a shot at it. SP5, 278 degrees, SP1, 191 degrees. That's about 80-degree difference. Use the right hopper insert. I'm going to flip through this one here real quick. I'm going to show you another video. What happens when you run the insert low again? You can see the blemish there and there. The lighting is pretty poor. Hope you guys can see it. You see it right there? He has the right insert, but he's running his insert too low. And if you look closely at the paver, you will see that segregated material coming out. See all the large stones coming out of there? That will be placed right about under the bearing hanger, which is the wheel pad. But the good news is, if you see blemish on the mat, you can find it in your paving train. Okay, so if we use the proper insert, we can minimize that segregation coming out of the insert, because it's the last time we're handling it. Here we have an insert where the opening at the bottom between the front opening and the rear opening is 8 inches apart. So that allows all the segregated stones coming along the sidewall to spread and not be concentrated. And if we have all the right augers, we can further remix it so that it's not concentrated. We use that baffle to allow the material to funnel straight into the flight chain and not roll to the side. Sometimes we need some more material, so if we fill the whole insert, we can probably get 25 tons. If we're going along nice 12-foot lane, we can get away with 18 tons and not overload our machines. And that's still enough material to exchange truck without running that insert low. If you have the front much wider, you don't want that material in the front there to sit and get cold. If you look at some insert, the front of the insert is in line with the front rubber of the hopper. From the front rubber to where the flight chain starts is roughly 18 inches. That's dead material sitting there getting cold. But if your insert opens right where the flight chain starts, then all the material constantly flow into the flight chain and you don't have any cold material sitting around. This picture is about 50 years old. It came out of the Army Corps of Engineers, Handbook of Paving. How many times we go out on a job site and we still see it? Center line, at the edge of the main, bearing hanger, edge of the main frame, and at your joint, the end gate. So we know what's going to happen here is premature failure. So this streak and that streak, we can manage by what we do when the tractor is delivering the material to the screed. Like we showed you earlier, we can position a reverse flight to push that segregated material out from under the auger box so we don't get that streak. I have two videos here we'll show you, one with the both auger flights doing this. If you look carefully right here, you will see both kicker paddles is pushing the large stone smack in the middle of the auger box. And that will leave a streak like we see on the picture. So to avoid that, we set one of the paddles to push. One of the paddles to push whilst the other paddle is pulling to move that segregated material out. Every paver have the ability to do that. Not one arrangement work for all application. You got to look at your challenge and you got to figure what solution you need. And not all mix segregate. So the last one is under the bearing hanger. So use your reverse kicker paddles and make sure your augers are turning continuously, because if the augers are not turning, you're not doing any remixing. The last one is under the bearing hanger. In this case, use all the auger extensions you can. Use your tunnel extension, retain that mix in the augers so you get the proper remixing, so you can eliminate that blemish under the auger bearing. And come back to, like I said, if you see blemish with continuous straight line, it's a screed adjustment issue. If you see blemish that are sporadic, even though this is continuous, but it's not a defined line, it's segregation. All the videos I showed you, you can see the segregated material. So if you see segregation, follow it to the augers. If you don't see it there, look in the hopper. If you don't see it there, look in the truck or the material transfer. I guarantee you will see it. And if you see it, you'll know what to do with it. So continuous straight line, screed adjustments, sporadic blemish, or continuous but not a defined line, segregation. I don't know of anything else that will create blemish on the pavement. It's either screed adjustments or segregation, one or the two. And I showed you that one before. So what are some of the technologies we have today to help you sit in your office and do a better job managing your project? So like I said, some states today are specifying a thermal camera to take a reading every 12 inches of the 6 feet behind the screen. Take that back and run your analysis. We also have, many states today are requiring the data to go from the camera to the analysis computer through the cloud. So you don't manually handle the data. To do that, you need a device to take the data from the paver and send it to our servers through cell signal. That device can create a Wi-Fi. You can take an Android device, scan a barcode on the paver control, and that Android device will show you your thermal camera if you're anywhere between 250 foot of the paver. You can see the thermal profile, you can see your paving distance, you can see your paving speed, your paving width, all that information that you need to manage your job. I can take an Android device, put it in the breakdown roller cab, and he can see his temperature, where he's at. So he knows where to hit a little bit more or less. At the end of the day, or if you end the project, we'll send you a report that shows you, in this case, blue means the paver was in pave mode and it was moving. That means we were paving. Orange means the paver was in pave mode and it was sitting. That means we're waiting on truck. And then the other color indicate traveling to the job site and maneuvering into position, that kind of stuff. So you get a report. If you really want to manage your job, you tell your operator, hey, every hour or every bridge deck, end that project, start another one. So you get a report in your office. You also get a thermal profile. So we also give you the square foot paved. So if you know your square foot paved, you know your depth, you can look at your yield constantly. All of this information is at your fingertip. What are some of the states doing today relative to EPDs? This is one of the things we were asked to talk about, sustainability, even though it was not on the topic. But like I said, this is what we presented. So this is a slide that came from NAPA. EPDs is Environmental Product Declaration in terms of CO2. So, like I said, this slide came from NAPA. This is not my slide. But if you look at their focus, they have A1, which is the material used, that will be your aggregate and asphalt. A2 is trucking the aggregate to the plant. A3 is mixing it in the plant. And then A4 and A5 is transporting it to the job site. A5 is laying it. All right, those are the 5 steps that they're monitoring in terms of EPDs. So if you look at A1, 95% aggregate, 5% asphalt binder. If you look at this chart here, you will see the most significant piece is A1, A2, and A3. That's where most of the CO2 comes from. If you look at A4 and A5, you notice A5 is not even mentioned. So the biggest challenge to control CO2 is A1 through A4. But we know A5 is important. We have been looking at A5 from 20 years ago. How many of you guys remember going from tier 0 to tier 2, tier 3, tier 4, tier 5? Today we have tier 5. All of that was done to control the emissions coming out of the pavers. There's a bunch of other features that we have been working on to reduce fuel consumption. So if you look at our paver today, we don't have a DPF. We don't have a particulate filter. So if we don't have a particulate filter, we don't need to worry about regen. If we're not regenning, we're consuming less fuel. So these are some stuff that we have been doing as manufacturers to control the emissions coming out of our paver. We have an eco-engine RPM. So if you're not paving, you're sitting there idle, the engine automatically comes back to idle. Once you start paving again, you stroke the F&R lever, the paver jumps up back to whatever RPM you chooses, and will come back to idle once you bring the F&R lever back to neutral. We put a clutch between the engine and the pump drive gearbox. So if you're sitting there waiting on trucks, the clutch disengage all the pumps, so only your engine is turning, and you reduce your engine load, reduce fuel consumption, reduce wear and tear on your pumps. So these are all stuff we have been doing as manufacturers to minimize the emissions. What else? Well, everybody has electric heated screed today, but our generator is plugged into the pump drive gearbox, which is a more efficient efficient drive compared to a hydraulic drive. Our fan that cools the engine is hydraulically driven, controlled by a couple of different temperatures. So the fan is not sitting there running at full RPM all the time. It only turns at the RPM it needs to keep the engine temperature where it needs to be. What else we have done? We put a diagnostic system on the paver. When we think about sustainability, think about when the paver goes down. How many trucks we have on the road, how many rollers we have, how many pieces of equipment is sitting idle. We put a diagnostic system on the machine that you can troubleshoot every electrical function on the machine if there's a problem. You don't need a computer, you don't need online service, it's there on the machine, you just need to learn how to use it. We put all the valves in a position where you stand on the ground, you open the side door, and you have access to everything. So we make it easy for you to troubleshoot, and we make it easy for you to fix. So we can reduce that downtime and get back on the road and start paving again. Another system we have where you can sit in your office, see what the machines are at. Now today, not all equipment have this yet, but some equipment already starting to have it, where you see the location of the machine, and you can see the consumption, you can see how much fuel is in the machine, how much DEF is in the machine, and you have a full printout of your fuel consumptions and your CO2s. Not all equipment have this yet, but we're eventually moving into having every piece of the equipment on this system that you can sit in your office and you can monitor what it's doing. It can show you how wide you're paving, how thick you're paving, what the mill is cutting, all of it in your office so you can manage your project better. All has to do with sustainability. Any questions?